Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the feedback or the concurrence from each one of you regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat. So at least I'll have the fair idea that each and everything is properly transmitted from my side. Each and everything is being properly transmitted from my side. The agenda behind the series of the engineering mathematics which we have been running so far had been very precise and clear. We are learning the each and individual concepts of the engineering mathematics from its very basics. At very first lecture we were discussing about the logarithmic function. Once we were done with the first video, we were discussing about the straight line, then we discussed about the parabolic function, hyperbolic function, circular function, and there are little small concepts which we have dealt, like the concept of tangent and all. Yes. So I would expect the quality of audio as well as video which is getting transmitted from my side must be perfect. Okay, perfect. So Pranali have said the perfect from your side. So we have reached into the 14th lecture of the engineering mathematics, and in today's lecture my motive had been very precise and clear. We are going to discuss about the limits, because I have seen at least one question do appear in your GATE examination from the department of the engineering mathematics. Like you must have been seen many of the times the problem has been related to the limit x tends to 0 sin of x divided by of x. Similarly, limit x tends to pi by 2 mod of 10x divided by x. So what I feel, many of the times the student know about the procedure through which they can get the limit of a certain function, but exactly they do not know the basics behind the limit, why the limit calculation itself is required. So what I have been saying, we are going to learn each and individual thing from very basic onwards. So even we will try to understand the concept of the limit from the very basics. So what I am going to do over here, without getting delayed, let me straight away jump into the working board, and here we are going to write the topic which we are going to start is gonna be limit. So each one of us should write the topic which we are going to cover in today's lecture is going to be limit. Although the agenda behind today's video is not to take the numerical problem based on the concept of the limit, we'll try to understand from where the concept of the limit have come and what we try to infer by calculating the limit. Yes. So the heading of the topic had been limit. The first important point goes under the limit. How the limit has been written mathematically. Definitely, if you have been dealing with a single variable function or single variable independent function, so obviously the function would be f of x. In future it could be f of a, f of g, f of y. But yes, as far as the limit is concerned, the limit which we are going to deal at least in today's video is gonna be single variable function. And what you do, you apply the limit where f of x must be reaching at a, So how the mathematical is being represented? It is being represented as limit x tends to a of f of x. Second important point, what does it mean by limit x tends to a of f of x graphically? We are going to draw a number line. Let's take it has been a number line. And as far as the f of x is being concerned, let's take it has been a function sort of this. It has been your function f of x. And let's take it has been x is equals to of a. What does it mean by limit x tends to a f of x? Limit x tends to, that means you are not precisely reaching to x is equals to 0, x is equals to a, you are pretending to reach to x is equals to a. That is why the word has come into the picture, and that has been tends to. May I know how you can tend to x is equals to a? There are two different methodology through which you can tend to x is equals to a, either from the left hand side, either from the right hand side. If you are reaching towards x is equals to a, or whether you are tending towards x is equals to a from the left hand side, it would be called as a left hand limit, and similarly if you are tending towards right hand side, it would be called as a right hand limit. Could you understand what I am saying? So there are two methodologies through which you could have reached towards x is equals to of a. This has been the first method or the first way, where you have started from the left hand side and you are trying to go towards x is equals to a. There could be the second way. The second way could have been, let's take the color, different way. This could be the second way. Just a minute. Let me change its position. there could be the second way. Yes, as you have been reaching to x is equals to a from the left hand onwards, so the limit which you will be pretending at x is equals to a would be left hand limit, and similarly here it's going to be a right hand limit. And it has been clearly written, we are trying to tend towards x is equals to a, we are not going to reach precisely at x is equals to a. So may I know exactly at which particular point I would be reaching once I take the reference of left hand limit? Obviously you would stop yourself precisely at x is equals to of a minus, and similarly once you start from the right hand side, and if you pretend to go towards x is equals to a, you are not going to reach exactly. So obviously you are going to reach at x is equals to of a plus. X is equals to of a plus. What you are going to do over here, now you would be calculating the worth of the function at x is equals to of minus a, and similarly you would be calculating the worth of the function at x is equals to of plus a. What had been the values? Here the value had been the worth of the function at x is equals to of a minus, that had been f of a minus, and similarly worth of the function at x is equals to of a plus had been f of a plus. Could you understand? So I would like to ask from each one of you, could you really understand what exactly I wanted to say? As far as the limit is concerned, mathematically it's been written as limit x tends to a. That means my approach is tending towards a for the function f of x. Tending towards a, that means precisely we are not going to reach at a. I would try from the left hand side, I would try from the right hand side, and I would just try to tend towards a, and I would stop myself at a minus as well as a plus. I would be calculating the worth of the function at a minus, that would be f of a minus, and similarly I would try to get the value of the function at f is equals to of a plus, and that would be equals to of f of a plus. Could you understand? So here what had happened, so two of the results we are getting out of this. The left hand limit when you approached towards a from the left hand side, and that has been f of a minus. May I know what is the a over here? The a had been the test point, or the point at which the limit has to be calculated. Mathematically speaking, this could have been calculated as f of, where you have to precisely mark yourself. Here it becomes a minus of h, where limit h tends to 0. What does that mean of it? That means you wanted to calculate the worth of the function at a minus of h, where the h is tending towards 0. So obviously a very small negative value, very small value would get subtracted with a. Put together you have been reached to f of a minus. Similarly, in the same sequence we can define a right hand limit. What does that mean by the right hand limit? The worth of the function which has been approached at x is equals to of a plus. That has been f of a plus. How mathematically this can be written? The same concept we can apply. Now the worth of the function has been assessed at a plus of h, and now what I am going to do over here, the h has been brought towards 0, and once the h has been brought towards 0, obviously a very small positive quantity is going to get added with the a. Put together somewhere you are going to reach at f of a plus. May I know when the limit does exist? That's the important one. When the left hand limit, or that means the worth of the function, when you have been swinging yourself from the left hand side, and similarly worth of the function when you are approaching towards a from the right hand side has to be very same. That indicates the left hand side has to be precisely equals to of right hand limit. How the mathematically it can be written? The mathematically it can be written as f of a minus is equals to of f of a plus. And even if you want to go more mathematical, so you can write this as limit of h tends to 0, or f of a minus of h, and has to be equals to of limit h tends to 0, f of a plus of h. Would like to ask from each one of you, till this point probably each and everything must be clear to all of us. If it is clear, just write clear over the live chat, so at least I'll have the fair idea that you guys are following me perfectly. Let me do one thing, let me move forward. This was the mathematical approach to calculate whether the limit do exist or not. My dear friends, may I know what would be the approach with the help of graphical? What would be the graphical approach to know whether the limit do exist or not? My dear friends, if f of a minus and f of a plus had been the same, What I am saying, if f of a minus as well as f of a plus has been the same, what does that mean of it? That means just before a and just after a, there should not be any sudden change. If the sudden change takes place, obviously the worth at a minus as well as the worth of the function at a plus would not be same, and if they are not same, obviously the limit would not exist. The limit would not exist. Could you understand what I am saying? So here the basic approach had been, if the value of or the worth of f of a minus of f of a plus had been very same, obviously the limit do exist, and that is the answer of that limit. Limit exists. If we have come across a situation where the worth of the function, when we have been tending towards a from the left hand side as well as right hand side, has not been same, keep in mind the limit does not exist, and hence you cannot write this perfect answer at x is equals to a, at x is equals to a. So you can write, if there is sudden change, if there is sudden change, you can write over here, if there is sudden change, there is sudden change, at x is equals to a, at x is equals to a, then limit fails to exist, fails to exist. So few of the important conclusion which we have derived, this has been this, just a minute, this has been this, and similarly few more important conclusion which we have derived over here, that could be this, that could be this. These are the important conclusions. These are the important conclusions. So let me do one thing, let me move forward and let me take few number of examples. With the help of those examples, we are going to learn whether the function do exist at its limit at a given test point or not. Let me take few number of numericals and we'll try to understand those numericals graphically also. Let me take the first problem. Limit x tends to maybe 0, sin of x. Tell me whether the limit do exist for the sin of x or not. Obviously, because if you will thoroughly watch the sin of x curve, it used to be continuous throughout the span of x. That means there would not be any sudden change throughout the range of x, which starts from minus infinity till plus infinity. That means there is no doubt as such. If we will talk about the existence of the limit of sin of x at any precise value of x, maybe at x is equals to 0, x is equals to pi by 2, 3 pi by 2, minus pi by 2, minus 3 pi by 2, definitely the limit would exist. The limit would exist. So if I would ask, would you get the precise answer? Yes sir, precise answer would be known or would be assessed. How? Because the limit x tends to 0 of sin of x is a valid question and the limit do exist. Limit do exist. Limit do exist. Yes, till this point each and everything must be clear to all of us. See what is happening over here. May I know what would be the worth of limit x tends to 0 of sin of x? What would be the worth of the limit x tends to 0 sin of x? See what is happening over here. The sin of x had been a continuous function. If the sin of x had been a continuous function, rather calculating the worth at 0 minus or 0 plus, you can simply calculate the worth of sin of x at 0 itself. Why? Because once we will be discussing about the continuity of the function, you will get to know when a function is said to be continuous at a certain test point a, when its left hand limit is very same as right hand limit and it is precisely same as the worth of the function at x is equals to a. Worth of the function at x is equals to a. What does that mean of it? That means if a function is continuous at a certain point a, by default its limit do exist. And as far as the sin of x is concerned, it has been continuous throughout the length. That is why these three components are going to be same together. By default, this starting two components are going to be same together. So what has happened over here? One thing is quite sure. The sin of x had been a continuous curve. Once we draw the sin of x, obviously we don't have to lift my pen. So one thing had been quite sure. The value of sin of x had been what? Continuous. So if you are interested finding its limit, f of a minus has been f of a plus. You can simply calculate this worth by keeping x as 0 itself, and the worth had been 0. Worth had been 0. Yes, worth had been 0. Let me take the next question. Deliberately, I have been taking the next question, which is bit tougher inside. Let's take the next kind of the problem had been limit x tends to 0 and it has been 10 of x. It has been 10 of x. First, you should have the clear-cut idea whether the limit would exist or not. If it exists, may I know what would be the bestmost answer? Although the 10 of x is concerned, it has been a discontinuous function at the prefixed values of x, like at pi by 2, 3 pi by 2. But as far as the 10 of x is concerned, at x is equals to 0, it has been a continuous function. And if the 10 of x had been a continuous function at x is equals to 0, you are interested finding the value of f of 0 minus f of 0 plus, rather focusing over the f of 0 minus f of 0 plus. Why don't we simply calculate the worth of the function at x is equals to 0 itself? Because the function had been a continuous function. So here we can write 10 of 0. Many of the times I have seen the student think, whenever the question do come based on the concept of the limit, like limit x tends to 0, 10 of x, simply they had to feed x is equals to 0. This is not the correct case, because the 10 of x had been a continuous function at x is equals to 0. So rather focusing over its left hand limit as well as right hand limit, simply you are focusing over the worth of the function at x is equals to of a itself. Yes? Could you understand what I am saying? So graphically, if you want to see how it would look like, graphically the 10 of x has been elaborated when I was discussing about trigonometric functions. So how the curve looks like? The curve looks something like this. It used to be sort of this. Yes. Here it has been 0 radian and here it has been pi by 2 radian. Here it has been pi by 2 radian. So obviously the answer is going to be 0 over here. The answer is going to be 0 over here. In the same sequence, what I am going to do over here, let me frame the next kind of the problem, and here the limit for the same function which had been 10 of x has been taken at around pi by 2, at around pi by 2. May I know what would be the bestmost answer? So here it had been 0 pi, here it had been pi by 2 radian, here it had been pi radian, so on and so forth. It has been keep moving. It has been keep moving, and similarly here it goes minus of pi by 2, and towards left hand side it would be keep moving like minus of pi, minus of 3 pi by 2, minus of 2 pi as it goes towards right hand side. As it goes towards right hand side, may I know what would be the bestmost answer? I would like to have the answer from each one of you. It has been the third question of the day, so definitely you can write 3, and in near to t or in adjacent to 3 you should write what would be the bestmost answer for the problem limit x tends to pi by 2, 10 of x. The Manju Sadhukaran is saying infinity. May I know? Anyone else who would be able to guess the bestmost answer for the limit x tends to pi by 2, 10 of x? X tends to pi by 2, 10 of x. I want at least one reply more, so I'll have the fair idea that you guys are able to visualize the basic concept which has been dealt so far. My dear friends, the limit does not exist. Limit does not exist. That is what I am saying now. Until and unless you are not well acquainted with the basic most theory of any of the portions of the chapter, you may not be able to actually get the exact answer. See what's happening over here. You have been reaching towards pi by 2. There are two methodologies through which you can tend towards pi by 2, either from the left hand side, either from the right hand side. If you've been tending towards from the left hand side, you would stop yourself just before pi by 2, and that is nothing but the pi by 2 minus. That has been nothing but the pi by 2 minus. And at pi by 2 minus, may I know where the worth of the 10 of x is going to shoot? That is going towards plus of infinity. Plus of infinity. And similarly, if you'll take the reference of pi by 2 plus, when it happens, when you are keep moving from the right hand side and you are tending towards pi by 2 and you have stopped yourself at pi by 2 plus, and at pi by 2 plus you would be seeing the magnitude, not magnitude precisely, the worth of 10 of x was reaching towards minus infinity. Minus infinity. Yes, till this point probably each and everything must be clear to all of us. See what is happening over here. The function has not been continuous. There is no doubt as such. The function has not been continuous. So we would be focusing over its left hand limit as well as the right hand limit. So why don't we calculate the limit x tends to pi by 2 minus, or rather doing this all, you can just focus over the worth of the function at x is equals to of pi by 2 minus, and similarly worth of the function at pi by 2 plus. The worth of the function at pi by 2 minus had been plus of infinity, and here it had been minus of infinity. You yourself would be able to understand the left hand limit has not been same as right hand limit, or graphically you yourself would be able to understand there has been the sudden change. it was going towards plus infinity, and once you go to pi by 2 plus, suddenly it has been started from minus infinity. It has been started from minus infinity. Yes. So till this point, probably each and everything must be clear to all of us. May I know whether the limit do exist for this problem? No, the limit does not exist, at least for this problem. Till this point, each and everything must be clear to all of us. In the same sequence, let me go ahead. Let me take a fourth problem. The fourth problem had been, which type of problem we can take? Let me take a rectangular hyperbola, which had been 1 upon of x square. 1 upon x square, how it looks like over the 2D plane has already been discussed when we were discussing about the rectangular hyperbola, where I was discussing about 1 upon x, I was discussing about 1 upon x square, 1 upon x cube, 1 upon x to the power of 4. So obviously, you must have the fair idea about the 1 upon x square, how it would look like. As far as the positive values or the negative values of x are concerned, the x square would always make those values as positive. And once the x square is positive, by default 1 upon x square is going to be positive. That means the worth of the function would always be positive for all positive as well as negative values of x. For all positive as well as negative values of x. So one thing is quite sure, the function would be there in first as well as second quadrant. The function would be there in first as well as second quadrant. So how the function looks like? For that, what I am going to do over here, let me draw a xy plane. Here goes the vertical axis. Here comes the horizontal axis. The horizontal axis has been marked as x-axis, vertical axis has been marked as y-axis. As far as the 1 upon x square is concerned, obviously y would always be positive, and hence it would be leading in first as well as fourth quadrant. And as the value of x is keep increasing in the negative sense or in positive sense, definitely as being inverse component towards x square, obviously the worth is continuously going to go down. So what is happening over here? As the value of x is keep increasing, worth would go down, and similarly here also worth would go down. So may I know what would be the worth over here? If you do the testing just before 0, that has been 0 minus, that means you have been keep moving from the left hand side towards 0, and you have tends to 0 obviously till 0 minus, and here it becomes 0 plus. May I know what had been the worth of 1 upon x square at 0 minus as well as 0 plus? What had been the worth of the function at 0 minus as well as 0 plus? Both had been reaching towards plus infinity. Precisely at x is equal to 0, obviously the function has not been continuous, but one thing had been quite sure, the function would always be reaching at plus infinity if you take the reference of 0 minus and similarly 0 plus. So one thing had been quite sure, what had it been? There had not been any sudden change, and if there is no sudden change, obviously the function would have its limit. May I know what would be the best most answer? I would like to ask from each one of you, what would be the best most answer for this given problem? Tell me what would be the best most answer for this given problem. What would be the best most answer for this given problem? See what is happening over here. If we'll be talking about this left hand limit as well as right hand limit. So left hand limit and right hand limit, that means you wanted to approach the function from left hand side, from right hand side. The worth had been plus of infinity. There had not been any sudden change at x is equal to 0, so obviously the limit do exist at x is equal to 0. May I know what would be the worth over here? The worth is gonna be plus of infinity. I have seen, yes. No, only it should not be written as infinity, it must be written as plus of infinity. In the same sequence, let me design the next question, and probably the student who have been attending my lecture continuously must be able to crack this answer very well, and it has been limit x tends to 0 of 1 upon x cube. Tell me what would be the worth of the limit when 1 upon x cube had been approached from the left hand limit as well as right hand limit. Tell me what would be the best most answer. Limit x tends to 0, 1 upon x cube. See what is happening over here. As we had the odd power of x, so what is happening for the all positive value of x, this would be positive, and for all negative value of x, this would be negative. That means the curve would belong in first as well as third quadrant. And when I would try to go, or I would try to reach towards 0 minus, obviously the magnitude would reach to the minus infinity, and similarly when I would take the reference of f of x at 0 plus, the worth would try to go towards plus infinity. Could you understand what I am saying? How the curve would be? The 1 upon x cube would be towards the positive value of x, there would not be much change in curve, but towards the negative value of x, the complete curve would null down or would get flipped towards third quadrant, would get flipped towards third quadrant. So may I know what would be its left hand limit as well as right hand limit? Left hand limit as well as right hand limit. The left hand limit is simply gonna be minus of infinity, and the right hand limit is simply gonna be plus of infinity, and there had been the sudden change at x is equals to 0. So one thing had been quite sure, what it is, sir? The limit do not exist. Limit do not exist. Agreed. Yes, the limit does not exist. Till this point, probably each and everything must be clear, or ultra clear to all of us. Must be ultra clear to all of us. In the same sequence, let me move forward. And let me take few more number of questions. I would request to each one of you, you can just share this link to our Telegram group, so most of the students may get benefited from our lecture. Yes, limit does not exist. In the same sequence, let me take the next question. The question had been limit x tends to a, and here you had a polynomial. Let's take you had a quadratic polynomial. It has been a1 of x square plus of a2 of x plus of a3. Precisely speaking, you have been applying the limit over a quadratic equation. Quadratic polynomial, and obviously a had been a real number. Sir commented the answer on last video. Please reply on that. Obviously, Himanshu Bharti will try to see that, because I was checking probably morning around 9 to 10 am. Till that, no reply had come. But now I'll check. Definitely, I would reply there itself. So you can write somewhere. All of the polynomials are continuous in their domain. You can write. All of the polynomials are continuous in their domain. It could have been like 1 into of x square plus of 2 into of x plus of 3, or maybe a which had been 1 into x to the power of 3 plus of 2 into x to the power of 2 plus of 3 into x plus of 1, so on and so forth. See what is happening over here. What I try to say, whenever you have a polynomial function, no, by default that used to be continuous, and if it used to be continuous, by default the limit would possess. So what I am saying, in future you may encounter the problem related to, like, you may get encountered with the problem sort of limit x tends to do 2x square plus of 3x. Obviously it has been a pure polynomial, and as the pure polynomial had been a continuous function, so without giving a second thought, simply you can feed x is equals to of 2, whatever the answer you get out of it, that has been f of 2. And once the function had been continuous throughout its domain, what happens at x is equals to 2, at x is equals to 2 plus, at x is equals to 2 minus, the worth of the function is going to be very same. And as you have been interested finding the value of f of 2 minus as well as f of 2 plus, but you are getting the value of f of 2 easiestly, so obviously why don't we do so? So f of 2 had been simply equals to, we would feed the x as 2 over here. So here the result what we are getting, 2 to the power of 2 or 2 raised to 2 had been 4. 4 is getting multiplied with 2, that would be 8. 8 is getting added with 6. End of the day, the result what we are getting in the hand is going to be 14. It's going to be 14. And as the function had been continuous through its domain, so the worth of the function at 2 minus 2 plus has to be very same as the worth of the function at 2. That has been 14. So hence the limit of x tends to 2 of 2x square plus of 3x would be equals to 14. Till this point, probably each and everything must be clear to all of us. Yes, in the same sequence what we are going to do over here, let me move forward into the next problem. Let's take the function had been x divided by of x plus 1. So far the different kinds of the problem which we have seen, there the test point were prefixed. Where the analysis of the limit has to be made. But here I did not take any of the prefixed test point. Now you have to just comment the point of x at which the function would not exist its limit. Tell me what would be the best most answer. Tell me what would be the best most answer. the value of x at which the function would not exist, its limit. See, whenever you have the polynomial towards the denominator side, whereas the pole and zero cancellation is not possible for that given problem. What I am saying, whenever you have the polynomial towards the denominator side, where the pole zero cancellation is not being possible towards the numerator as well as denominator, what we do? We used to calculate the poles from the given polynomial. How the poles is being calculated? The poles are nothing but the roots of the polynomial which have been there towards the denominator side. So may I know what would be the worth of x over here? The x had been precisely minus 1. The x had been precisely minus 1. Yes, we have started getting the answer. X had been precisely equals to minus 1. So if you would like to get the value of limit at x is equals to minus 1, obviously the answer is going to be something different. Is it so? Is it so? Is it so? Tell me. Is it so? I know still many of the students are going to do the mistake over here. Or everything is fine. Everything is fine. See, just try to understand. If you would like to calculate the worth of the function at minus 1 minus, that means just before minus 1. See what is happening over here. Lump sum the worth of x would be minus 1. And towards the denominator side, what's happening over here? The x has been fed as minus 1 minus. What does it mean by the minus 1 minus? Many of us may not be able to understand. Minus 1 minus is very same as minus 1.00000000001. 1. Yes. And once you'll add them together, may I know the magnitude of which worth is larger? Whether this one or this one? Obviously this one. This one. So end of the day, the result what we are getting is simply going to be minus 1 divided by of 0 minus. Yes, my dear friends, as far as the magnitude is concerned, almost their magnitude had been 1. Polarity had been reversed. Obviously once you subtract them together, the worth would be 0. But the polarity of 0, would it be positive or would it be negative? That would just be asked from the value which had been greater in magnitude. Obviously this value had been the greater in magnitude, so obviously it becomes 0 minus. So here what is happening? 0 minus, that means you can assume like minus of 0.000000 and goes like 0.1. See what is happening? The minus and minus sign goes out. The result what you are getting over here had been plus of infinity. It had been plus of infinity. If you want, we can show over the 2D graph. There is no doubt as such. Similarly, let me focus over right hand limit. What does that mean by the right hand limit? That means we are keep proceeding towards minus 1, and definitely the path which we have taken that has been is initiated from the right hand side, and we are keep moving towards minus 1. So obviously I would stop myself at minus 1 plus. The same calculation has to be made over here. X magnitude wise, it could be simply written as minus of 1. Yes, even if you take plus or minus, still the polarity as well as the magnitude would not change. See what is happening? Yeah, asymptotes, that's fine. No, that's fine. See here what is happening over here, and once again you would be feeding the x as minus 1 plus, and you would be added with plus 1. What is happening over here? Numerator had been minus of 1, and at denominator you had 0. May I know you had the 0 minus or you had the 0 plus? If the polarity of the negative sign had been more, obviously you would be leading with the 0 minus, otherwise you would be leading with the 0 plus. What the minus 1 plus indicates? You have been keep approaching towards minus 1. That means you could not approach to the minus 1. You have been stopped yourself somewhere at minus 0.99999 something. So end of the day, the result what you are getting out of this is simply going to be minus of x divided by 0 plus. Upside you have got a positive negative value, downside you have got a positive value. The result what we are getting is simply minus, and 1 upon 0 would lead minus of infinity. So obviously, as far as this problem is concerned, x is equals to of minus 1 had been its pole, or it's also called has been its asymptotes, and here the function had been discontinuous, because once you will take the reference of minus 1 minus, the magnitude worth of the function was reaching towards plus infinity, otherwise it was reaching towards minus infinity. For the better understanding, what I am going to do over here, I am just going to cross check whether it has been looking the same. Over the 2D graph or not. For that, what we are going to do over here, just a minute, let me see everything is fine or not. Everything is fine. Let me go back and let me cast my screen. Just a minute. So it is creating a new session. Let me see what has been the session ID. The session ID has been 163.163.867. Let me take the name as Sonal and let me go ahead. Yes, let me present my screen. Here goes my screen. Just a minute. Which application I use? Obviously, many of us, the student who have been attending my class since very beginning, they must be knowing about it. Yes, Desmos we use. So the function which we are going to enter over here had been x divided by 1 upon x. So what I am going to do over here, let me change the background of the color such that the visibility would be improved. And here it goes x and getting divided with 1 plus of x. See how the curve is looking like. You yourself would be able to understand. At x is equals to of, it has been minus 1, no? Yes. Just a minute. Yes. It had been x is equals to of 1 minus, and it had been minus 1 plus, and you yourself would be able to understand at minus 1 minus it was trying to go towards plus infinity, and if you will take the reference of minus 1 plus, it's going to be taking the reference of minus infinity. So may I know at x is equals to of minus 1 whether the function had been the continuous or it has been taken a sudden change. Obviously a sudden change has been experienced at x is equals to of minus of 1. Could you able to understand what I am saying? So I would like to ask from each one of you, could you really digest the concept which I wanted to clear through this 2D graph? If the concept is clear, just write clear over the live chat, so at least I'll have the fair idea. Yes? So let me go back. You yourself would be able to understand. At f minus 1 minus, the worth was plus of infinity. At f minus 1 plus, the worth was minus infinity. And that has been happened. When you were towards left hand side of minus 1, it was keep improving and was going towards plus infinity. And similarly, once you change your value of x a bit, you try to go towards minus infinity. Till this point, each and everything is clear. I would like to ask from each one of you, till this point, each and everything is clear or not? Probably must be clear to all of us. In the same sequence, let me take few more problems. Yes, sir, clear, no? Yeah. Let me go forward, or let me move forward. So here the problem which we have been dealing with. See which kind of problem it has been. We have taken x, and no. Let me move forward and let me take a problem, and the problem had been x divided by of. Let me take a problem. It has been 5x plus of 6. Deliberately I have designed this problem because this problem is going to give good amount of pain. Should I be repeating what you had to do? Obviously you had to discuss about the limit existence of this function and what are the different test point has to be considered throughout the range of real values of x. That means you had to start from minus infinity and has to go till plus infinity. Again, whenever you had polynomial towards denominator side, the roots of the polynomial or the denominator's polynomial would be the point of discontinuity, that is for sure, and even the limit would not exist over those points. How? We'll try to understand that. So what I am going to do over here, let me do one thing. Keep x as it is towards denominator side with the help of middle term split or with the help of variable separable. What you could have done, obviously you could have factorized this polynomial. This could have been written as x plus of 2, x plus of 3. Could you understand what I am saying? So what I am going to do over here, we are going to do the analysis at minus 2 as well as at minus 3. There is no doubt as such at minus 2 as well as minus 3, the function would not exist its limit, as it cannot happen in case of x is equals to of minus 1. Could you understand? Let me show how the curve would look like. The function had been x divided by of x square plus of 5 of x plus of 6. So let me go back. Yeah. So here it had been Here it had been x square plus of 5 of x plus of 6. See how the curve had been. Could you understand how the curve had been? So that is what I am saying. What are the different points at which the problem had happened? Obviously, those points were minus of 3. The points were minus of 3, and if you will go towards upside now, you will see there had been another change. Anyways, let me just reduce this function. So what is happening over here? If you really wants to know what has happened over here, at x is equals to of minus 3. Yes, minus 3. If you will take the reference of minus 3 minus, what has happened? The magnitude was reaching towards minus infinity. If you will take the reference of minus 3 plus, the magnitude was reaching towards plus infinity. Similarly, after 3, you had minus 2. At minus 2 minus, the magnitude was reaching towards plus infinity, and at minus 2 plus, the magnitude was reaching towards minus infinity. If you want to write, you could have seen this problem very well. There could be the different analysis. The analysis could have done over the minus 3 minus, minus 3 plus. Similarly, the next analysis could have been done at minus 2 minus and minus 2 plus. I am not going to solve this problem mathematically. With the help of their graph only, I am going to get their values. You yourself would be able to understand. At f is equals to of minus 3 minus, the worth of this function had been reaching towards minus infinity. Similarly, if you take the reference of minus 3 plus, obviously you have to just go towards a little bit right hand side of minus 3. You would be reaching to the minus 3 plus. May I know where the worth of the function has been moving? It has been moving towards the plus infinity. It has been quite sure the function had the sudden change at minus 3, because at minus 3 minus, or at left hand limit as well as right hand limit, the values were different. Yes. Similarly, at minus 2 minus, what is happening over here? At minus 2 minus, the worth had been reaching towards plus infinity, and here it has been minus infinity. Again, there had been mismatch between the worth of the function at a minus as well as a plus. So one thing had been quite sure. May I know what it is? The function limit does not exist at minus 3 as well as minus 2. So what would be the bestmost answer? Except x is equals to of minus 2 and minus 3. In short, except its real pole, the function would be continuous throughout the length. Could you understand in this way? In the same sequence, what we are going to do, we are going to change this problem, and definitely after changing, it would become a very beautiful problem. Let's take the problem had been x divided by of x square plus of 2x plus of 2. Tell me, would it be a continuous function or would it be a discontinuous function? And if it is a discontinuous function, may I know what are the different points where the limit would not exist? I know these are the problem where most of the students are going to get trapped. The problem had been x divided by of x square plus of 2x plus of 2. As we had the analysis earlier, all of the different poles or the roots of the denominator would always the point where the limit do not exist and the function continuity ceases. May I know what would be the bestmost answer over here? X divided by of x square plus of 2x plus of 2. Tell me, please comment over the existence of the limit for this given function. The function had been x divided by of x square plus of 2x plus of 2. See what is happening over here. Once you will be discussing about its poles, how the poles is being referred. The denominator has to get compared with 0. All of the different possible roots which would satisfy this equation by default would become its poles. May I know what are the roots we are getting? Once you'll solve with the help of Sridharacharya rule, the answer what you are getting is going to be minus 1 plus minus j. What has been the result? Obviously, there is no real value of x which is going to make your denominator 0. What does that mean of it? That means there is no discontinuity point at all, because discontinuity point would fall over the real number 9. Obviously, it could be at 1, it could be at 2, it could be at 3, it could be at minus 1, it could be at minus 2, it could be at minus 3. It can't be complex in nature. And as far as the roots of this polynomial is concerned, it has been pure imaginary. Not exactly pure imaginary, there had not been any real root. So one thing had been quite sure. What does that mean of it? That means there is no pole has been involved with this problem. So because of x square plus of 2x plus of 2, there would not be any discontinuity. There would not be any discontinuity. Could you understand what I'm saying? You can expect this sort of problem in gate examination, because many of the times this sort of problem have been coming in the gate examination, but this sort of problem I have never seen. If I take the reference of electrical, electronics, mechanical, civil, chemical, instrumentation, PY, chemistry, mathematics, EY, ecology, petroleum engineering, no, nowhere I have seen this sort of problem. Nowhere I have seen this sort of problem, because I have been teaching mathematics since 10 years and I had the flavor of all of the branches. Nowhere means nowhere. Nowhere. May I know what should be the best most answer? For the better understanding what I am going to do over here, let me go back to the 2D drawer. And this has been the curve for x divided by x square plus of 5x plus of 6. What I am going to do over here, let me change this problem a bit. It has been x square plus of 2x plus of 2. So here it goes. See, what a beautiful curve it is. What a beautiful curve it is. Just by changing the coefficient of the denominator's polynomial, you could have seen the function had been continuous throughout the length. The function had been continuous throughout the length. You yourself would be able to analyze there had not been any discontinuity, there had not been any sudden change. And as there is no sudden change, obviously, the limit would exist throughout the value of x. Throughout the value of x. Could you understand? If you could understand this concept well, I would like to ask from each one of you that you should comment the value as yes. You should comment the value as yes. Yes, comment the yes. Let me take the next question. Let me take the next question. Which question should I be taking? If I change this value as x square plus of 3x plus of 2, I would like to ask from each one of you. If I change this denominator's polynomial from x square plus 2x plus of 2 to x square plus of 3x plus 2. 3x plus 2. Now, the function would be continuous throughout its range, or it would become a discontinuous at a certain point. Could you understand what I am saying? The polynomial which were there towards the denominator side had changed its polynomial, worth it a bit. May I know? Now, if we have changed to this, it has been changed to 3 of x and it has been changed to 2. Again, you can see the discontinuity had been formed. Yes. Discontinuity had been formed. May I know where the discontinuity had been happened? Because again, the roots of the denominator had been real in nature. Obviously, the discontinuity points are the points where the real poles does exist. Could you understand? My dear friends, I would expect from each one of you, if you really able to connect with the concept, you should at least reply my vocation sheet, so that at least I'll get to know that you guys are able to follow my lecture well. Could you understand what I'm saying? So what I'm going to do over here, let me go back to the working board. As far as the next problem is being concerned, the problem had been x divided by of x square plus of 3x plus of 2. And once you'll calculate its pole, the pole would be fallen over minus of 2 as well as minus of 1. Both had been pure real. Obviously, x is equals to of minus 2 as well as x is equals to of minus 1. X is equals to of minus 2 as well as x is equals to minus 1 are the points at which the limit would not exist. That is for sure. There are been certain structure where yes, even it is not continuous. Yes. Let me go forward and let me take the next question. The problem had been, let's take 1 divided by of 1 plus of mod of x. 1 plus of mod of x. I need to get the limit of this function where the x has been tending towards 0. There could be the two different possibilities. What are they? The first possibility, with limit does not exist. The second possibility, limit do exist and you would be getting its precise most answer. Tell me what would be the best most answer for this given problem. What I am saying, once you would be dealing with this problem, there could be the two possibilities where the limit does not exist, doesn't exist. That could be the first possibility. The second possibility could be the limit do exist, and if it exists, obviously you had to get its precise answer. You have to get its precise answer. Tell me what would be the best most answer. Again, the same fundamental is going on. May I know when the denominator is going to be 0? The denominator is going to be 0 when the 1 plus of mod of x becomes 0. When the 1 plus mod of x would become 0, that would become 0 only and only when the mod of x would become precisely minus of 1. That is not at all possible. That is not at all possible where the x has been a real value. I am not going to deal with the complex number at all. So either you feed x is equals to plus 1, either you feed x is equals to minus 1. In both of the case, if you take its absolute value, the absolute value would always be positive. That is not at all possible to get mod of x is equals to minus of 1. Mod of x is equals to minus of 1. So one thing I had been quite sure. What it has been? Sir, I do not have any possible poles for this given function. That means this function would exist its limit throughout the range of x, If you want, we can draw over here, which we have drawn earlier, obviously. Probably in last video when I was discussing about the different curve, I could discuss a bit about it. So let me do one thing. Let me change this function and change it to 1 divided by of 1 divided by of 1 plus mod of x. It was probably, yeah. You can see very well. Although the cusp has been formed at x is equals to 0, but there has not been any sudden change throughout the range of x, and that is what I was looking for. Could you understand what I am saying? So end of the day, the conclusion which we are going to retrieve out of it, if you have the ratio of two different functions, let's take the function which were involved towards numerator had been taken as f of x, and similarly the function which were involved towards denominator had been g of x. And if you had to analyze about its limit existence as well as continuity, what you had to do? You had to factorize f of x as well as g of x. One thing is quite sure, both of them had been polynomial. What has been the nature of the polynomial had already been taught in earlier lecture of the series of the engineering mathematics. Both had been the polynomial. So what you are going to do first, you are going to factorize them. What does that mean by the factorization? Like you had x square plus of 3x plus of 2. You could have written that as x plus 2 into of x plus 1. Similarly, if you would have had x square plus of 2x plus of 2, you could have written that as x plus of 1 minus of j, x plus of 1 plus of j. So what we are going to do, we are going to factorize its numerator as well as denominator. And what we would do, the common factors would be knocked off. End of the day, what we are going to see, we are going to compare g of x with 0. All of the possible values of x which are pure real in nature would be the valid poles where just a minute, valid poles where limit as well as continuity would not exist. Could you understand what I am saying? So in the same sequence, let me take few number of problems for the better understanding. See, I could design the first problem as x plus 1, and at denominator I could have x square plus of I could have taken 3 and 5. So here it becomes 8 of x plus of 15. Obviously, towards the numerator side you had the polynomial, towards the denominator side you had the polynomial. So what we are going to do over here, whenever you have this sort of problem and you had to follow its limit, try to factorize. Numerator had been in power of 1, so obviously you need not to factorize it, but towards the denominator definitely you can do so. You could have used the middle term split, probably the things which you have studied in class 8th, 9th, 10th, 11th and 12th. So here it becomes x plus of 3 into, why it's happening so, just a minute. And here it becomes x plus of 5. So now end of the day, what you are going to do over here, the common factor which were there towards numerator and denominator would be knocked off. There has not been any component as such. So what you are going to do, you're just going to compare its denominator with 0. So may I know what are the real roots we have got it? It's a minus 3 as well as minus 5. So minus 3 as well as minus 5 are the points at which the function would cease its continuity as well as limit, because there would be a sudden change at that point. Could you understand? Similarly, in the same sequence, what we are going to do over here, Let me take, it had been x plus 1, it had been x square plus of 2x plus of, just a minute, 2x square plus of x. Deliberately I have designed this problem. Deliberately we have designed this problem. Yes. Tell me what would be the best most answer for this given problem. What would be the best most answer for this given problem? So again, once you will calculate, its pole, you will get to know only one pole had been pure real, and that has been at x is equals to 0. What has happened? Sorry, we are having temporary server issue. Okay, no issue. Tell me what would be the best most answer. So only one real poles you would be getting, and that has been at x is equals to 0. So obviously, except x is equals to 0, the function would be continuous throughout its range, and yes, even the limit would not exist at x is equals to 0, at x is equals to 0. So just wanted to know till this point each and everything is clear. If it is clear, just write clear over the live chat. I would expect from each one of you, the student who have been attending my lecture since very first day, or who have been following my lecture very frequently, whenever I ask any sort of questions, you must be able to reply, or you must reply. So I'll have the fair connectivity with you guys. So this is all for the today's video. In tomorrow's video, we are going to take few more number of problems based on the concept of the limits. Once we are done with the limits, we would move into the continuity. Once we are done with the continuity, we would go into the differentiability. Once we are done with the limit, continuity as well as differentiability, we are going to take the chunk amount of the problem based on the continuity, limit existence as well as differentiability, which has appeared in the different years of the GATE examination. So this is all about the today's video. We are going to meet at precisely 9 PM with a span of 1 hour. Till then, bye bye, take care, and yes, keep working hard. Good night.